Okay, we are going to jump into solving linear systems by graphing. So you're graphing lines and you're telling me where they cross. Okay? So if you have two systems, two equations, I can put both into y equals form, and then I can graph them, and then I can tell you the point at where they cross. This is why graph paper is very important for your homework. You need it to be exact, okay? So, if I have two equations, 4x plus y equals 8, 2x minus 3y equals 18, and it wants me to graph the system, estimate the solution, check the solution algebraically. What do I need to do to both of those equations first? Yeah, I need to put them into y equals mx plus b form first, like the y equals form first, okay? So that I can graph them. So here's the deal. If you did not graph lines well on last test, you gotta get it together because it's not going away. You gotta be able to graph a line, okay? So we are going to go ahead and put these into y equals mx plus b form. So if I have 4x plus y equals 8, what do I need to do first to get into y equals 4? Subtract the 4x, right? And I get y equals negative 4x plus 8. Okay? Now, the other equation is 2x minus 3y equals 18. Okay? What do I need to do first to solve this? Subtract the 2x. And I get negative 3y equals negative 2x plus 18. Now what do I do? Divide by the negative 3. I have two negatives here, so I get positive 2/3 x as my slope. And then what's 18 divided by negative 3? Negative 6. So now I have my two equations. Now I can graph those two equations. Let's start with this one. I counted by 2 on this graph. If I want to graph this, where's my y-intercept? 8. So I go 2, 4, 6, 8. And what is my slope? Down 4 over 1. Down 2, 4 over 1, which is halfway. Down 2, 4 over 1. Okay? And then I make my line. Okay? This is hard because I don't have a straight edge. You'll need to use a straight edge. Okay. Now here, what's my y-intercept? Negative 6, so I go down to 2, 4, 6. What's my slope? Up 2 over 3. Up 2 over 2, 3. Up 2 over 2. Over 3. Okay, so my line looks something like this, yes? Okay, and I want to estimate this point where they cross at. See that point right there where they kind of intersect? And I want to plug it in and figure out if it is a, what point it is of, if it works for the solutions. So I'm going to say that it's like negative 3, negative 4, okay? So negative 3, negative 4 is where they intersect. So I'm going to plug those in to both of these equations and see if that's a solution of both of these equations, okay? Plug in negative 4 equals 2/3 negative 3 minus 6. What's 2/3 times negative 3? What's 2/3 times negative 3? Negative 2. So negative 4 equals, that doesn't look right. Negative 2 minus 6. It can't be right. It has to fit into, watch this, wait a second. 2.
Isn't it positive 4?
It is positive 3, 4. I'm stupid. It is positive 3, 4. Good job, Katie. Like I said, 3, negative 4, and then I write negative 3. I have a problem. Okay, so it is positive 3, negative 4, right? So if I plug it in, this gives me positive 2 and negative 6, which gives me negative 4 equals negative 4. Okay. If I plug it in over here, and I plug in negative 4 equals negative 4 times 2 plus 8, is that right? No. Did I do it wrong again? Not 2. 3 plus 8, yes. Negative 4 equals negative 12 plus 8. What's negative 12 and 8 together? So negative 4 equals negative 4. So on your homework tonight, you're going to have to graph them. You're going to have to estimate the solution and plug them back in and check. Can you do that? Okay, I think you can. Yes, Mark.
Can you go over how you graph that?
You put it into y equals form. This is y equals form right here. This one and this one. This is your y-intercept. So that means I go to the y-axis at negative 6 and I plug in a point, 2, 4, 6. Okay? And then 2/3 is my slope. So you go up 2 over 3 from that point. So I go up 2 and over 3 and I make my new point and I can graph a line through there. Okay? So you have to use your y-intercept and your slope. Okay. So this is what we are working on today. We have 4 more slides. Okay. So there are 3 ways that you can get answers when you're graphing 2 lines. Okay? The first way is they can cross at exactly 1 point. Okay? If they cross at exactly 1 point, you give me what that solution is. You plug it in, you check it algebraically. Okay? Not too bad. You can do that. If the lines map out to be the same, if they are on top of each other, you have something called infinite solutions. Okay? Because it doesn't matter what point you put in, every solution is going to work because the lines are on top of each other. Okay? And then if you have parallel lines, you have something called no solution. Okay? Now, how do you know if lines are parallel? Do I even need to graph them? I don't even have to graph them because I can tell by equations. What tells me that lines are parallel? Their slope is what? The same. So if I have 2 equations and I see that the slopes are the same, I don't even have to graph it. I can just say no solution. Okay? Unless it specifically tells me to graph them on purpose. Okay? So when you have exactly 1 solution, those lines intersect all at 1 point. It's called a consistent and independent solution. Okay? Consistent and independent. Okay? Consistent and independent. When my lines overlap and are on top of each other, those lines coincide. It's consistent and dependent because they depend on one another. They're the same exact line. They depend on one another. Okay? When the lines are parallel, it's inconsistent because there are no solutions. So it can't even have any type of consistency going on. Inconsistent is no solution. Consistent and dependent is infinite solutions. 1 solution is consistent and independent. Okay, you're going to need to know those terms because they're going to have you match them with graphs. Okay, you're going to have to tell me when it says classify this, you're going to have to tell me there's no solution, it's inconsistent. You're going to have to tell me there's infinite solutions, it's consistent and dependent. And you're going to have to tell me there's 1 solution, it's consistent and independent. Okay, I'll leave it there for a second while we still copy stuff down. Because some of you are writing super fast. So tonight's homework, you should have lots of graphs going on, okay? Because the first section of your homework is going to be graph the linear system, estimate the solution, check the points out, like we just did. The second part of your homework is going to be solve the system, classify the system as consistent and independent, consistent and dependent, or inconsistent. And then you're going to just have a few word problems. And that's what your homework's going to look like, okay? So when it says solve the system, we're going to do it by graphing still, just so you know, okay? Or we're going to put in y equals, and sometimes we can see without graphing what's going on. Okay, that almost looks purple. It is?
The wall?
Yeah, the wall.
It's like, you got it in my house.
So we're going to do, I think, 3 more examples, and then I'll let you loose on your homework. look at this. It says solve the system, classify the system as consistent and independent, consistent and dependent, or inconsistent. So to solve the system, what do I need to do first? Yeah, put it in y-intercept form. I've got to put it always in y-intercept form. So my first equation says 4x minus 3y equals 8. Yep. How do I get this into y-intercept form? What do I do first? Subtract the x. Good. So I subtract 4x from both sides, and I get negative 3y equals negative 4x plus 8. Now what do I do? Divide by negative 3. And it's going to be y equals, those are two negatives, so it becomes positive, 4/3 x plus 8. My y-intercept is 8. My slope is 4/3. Oh, you're right, I didn't divide the 8 by 3. Gosh, Kaden, I'm struggling today. So negative 8/3, what is negative 8/3? 2 2/3? Okay, now, I don't want to graph that yet because if the other one happens to have the same slope, I don't need to graph them because they're parallel, okay? So I suggest you put both equations in y equals form first and then we'll graph and see, okay? Second equation is 8x minus 6y equals 16. So I subtract 8x from both sides, yep. And I get negative 6y equals negative 8x plus 16. Now I divide by what? Negative 6. What is 8, negative 8, and negative 6 reduced to? 4/3? Yep. 4/3 x plus, and what's, not plus, minus. What's 16 divided by 6? 2 and, it's 2 2/3? 16 divided by 6, yeah. I think so. So, question,
How do you
Okay.
do like the 2 and 2/3?
because I just put 16 divided by 6 in my calculator and you get 2.66. I know that 2/3 is 0.66. You can leave it as a decimal, I don't care. You can do it either way. I just put it in my calculator and reduce it down. Okay, so what does this mean when these lines are like this? Infinite solutions and consistent and dependent, right? Infinite. So do I even need to graph these? No. I'm telling you, you don't have to graph them if it comes out this way.
So you don't have to graph it if it's consistent.
Basically, yeah, because if it's consistent and dependent, they're the same line. And if it's inconsistent, then they're parallel, we know that. So I'm not gonna make you graph them, I'm trying to save you some time. Not gonna make you graph them if you don't have to, okay? That's why I said solve for both equations first, okay? Now on like the first section of your homework, it says graph these and then tell the algebraic solution. So clearly you're gonna graph all those. But on the second part where it says solve the system, if you solve the system and it turns out to be the same stinking line, don't graph it, save yourself some time, okay? Now, next one, we want to solve this system as well, okay? So, first I have 2x plus y equals 4, yes? How do I solve that? What do I do first? Subtract 2x. You need to make sure you show me this on your homework. Plus 4. So that's the equation of that line, yep. Next one is 2x plus y equals 1. So I'm going to subtract 2x. And I get y equals negative 2x plus 1. What happens when they have the same slope? They are what? Parallel, which means that they have how many solutions? No solutions, and it also means what? What's the classification for no solution? So I don't even have to graph these either. Okay? How's that? Does that make it easier? Okay, and then the last thing. You ride an express bus from one center of town to your street, from the center of town to your street. You have two payment options. Option A is to buy a monthly pass and pay $1 per ride. Option B is to pay $2.50 per ride. A monthly pass costs $30. After how many rides will the total cost of the two options be the same? So where will those two lines meet and be the same amount of money, is what it's asking. What do I need to do to solve this? What do I need to do? I need two equations, two. Okay, one for option A, one for option B. So let's look at option A. It says A is to buy a monthly pass and you pay how much per ride? $1 per ride, okay? But also something else comes with the monthly pass. It costs you what? So how can I set that up in an equation form? Y equals what? What's your initial cost? 30, okay? But how much does it also cost per ride? 1. Do we know how many rides we're taking? So I can just say 1x. So y equals 1x plus 30. Okay, that's our first equation. That's for option A. Now option B is to pay how much? $2.50 per ride, right? So is there an initial cost? No, it's just $2.50 per ride. So y equals $2.50 because we don't know how many rides. Okay? Now, what do we have to do with that information? What do you think? Graph it. Graph it. Okay? So, if I graph this information, I'm going to do it over here because it's going to be weird. Okay. If I graph this information, the first one starts at 30, correct? Okay. And it's going down 1 over 1, down 1 over 1, down, right? Okay. Okay. And then we're going to go 1, 2, 3, 4, 5. Okay. So if I go 30 and I go down 1 over 1, down 1 over 1, this is why we need graph paper. Okay. My graph is going just down like that, yes? Okay. Or not down 1, it's going up, isn't it? I'm being crazy. So up 1 over 1. Okay, so my graph should look like this. Okay, something along those lines. The other one starts where? 0, 0. Starts at 0, 0. Okay, so I'm starting down here at 0, 0. And what is my exponential growth on this, or what's my growth on this one? Up, how much? 2.5 and over 1. So 2.5 over 1, right? 2.5 over 1. Do you see how this is like 2.5 over 1? Okay, so I'm going to graph this line that goes this way, right? And this line's going this way, so they're going to meet someplace over there, right? Okay. So on your homework, that's why you need to use graph paper, because you'll be able to see it better than my graphing, okay? So if we graph that well, it would come out to them crossing at 2050, okay? Always plug your numbers back in and check to make sure it comes out, okay? And because you're rounding or estimating a little, it might be off by like a couple decimal places or something like that, that's fine, okay? But double check by plugging it in. Okay, but that's all that you have to do on tonight's homework. Graphing, taking that solution, plugging it in, and checking algebraically, and then the inconsistent, consistent,